smaller, 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 and smaller. When the further you go into the decoding process. What does that mean? That means you need more bits, more bits, more bits, more bits, more bits to describe the resolution of this range. Okay, and that's what makes arithmetic coding work. So intuitively, we keep on narrowing the interval. Okay, and the number that we will send to the decoder, I let you figure out why I picked that number. Okay, and then if I want to represent it using binary, then it's these guys. And in base 2, this is what happened. So I need 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 1, 1. That's what I'm going to send over to the decoder. How many bits is that? 16. Comparing to Huffman, 18. We save 2 bits. And just on a very short sequence, that gives you a very this is a very powerful statement, right? We encode a very short sequence, and we already gained 2 bits. Okay, imagine we have to send billions of bits over a communication channel. How much it's going to save you? Okay, so this is why arithmetic coding is better than Huffman, and the decoding process is this. And I'm sure all of you guys are smart. If you take a little piece of paper, you imagine that you are the encoder, you imagine that you are the decoder, you try to work forward, backward, you will figure out that, hey, I can actually decode based on just this particular numbers. I will be able to work backward and figure out that, yeah, it's x2, x2, x3, x3, x6, x5, x7. Okay? Because of the way we blow up the intervals. I show you how to do arithmetic decoding. And I believe I have a typo right here in the beginning. The range in the beginning should be 1, not 0 is, okay? But this is exactly how I decode. I figure out this formulas, and it's actually fall within this range, so it's x2. Okay, and then I follow up with another iterative process. Okay, now this is. Let me finish this, and then we stop. Okay. The adaptive arithmetic coding is this. I have 3 symbols. Okay, and I would like to do arithmetic coding without tabulating the frequency. Okay, I just do arithmetic coding along the way, just based and let the code evolve from the observed symbols. Okay. So how do I do? In the beginning, what do? I don't know anything about ABC. I don't know anything about the source. Okay. So the only thing I can do is to make the assumption that a third of the time is A, a third of the time is B, a third of the time is C. So then I'm going to do 1/3, 1/3, 1/3 like this. That's my original assignments. Okay. So then suppose that B comes, right? If B comes, I'm going to have to update my table, right? So now B has 2 bars, and A has 1, and C has 1. So I'm going to blow up first I'm going to try to blow up this interval in the middle. The interval in the middle will say 0.33, 0.666, right? But then when I partition the next subintervals, I will partition it with respect to the new count. So I'm not going to partition it with 1/3, 1/3, 1/3. Instead, I'm going to partition it with 1/4, 1/2, and 1/4, because B happens twice now. Okay, so it's going to be 1/4, 1/4. Okay, and if I receive C, I'm going to do blow up. I will do blow up from this here and that there, right? So I'm going to figure out based on 75%. Okay, I will be able to figure out that this number is 5834. This number is still 6666. Okay, and then the next C comes, so I receive another guy here. I will blow up. So this C will give me. I will have an updated count now. So this C actually get assigned 50%. Okay, and so as you can see, this is highly evolving. Okay? Now, the question is, how do we actually decode? Does that actually work? Any idea? When you decode, what do you first start? You don't start with that one. You start with what? 1, 1, 1. You start with 1, 1. Agree? Okay? You start with 1, 1, 1. And then you are sending this number over 0.6396. And I take a look at 0.6396. I know that it's B because it's in here. Okay? So what did I do? I know that it's B. I decode B. Then I update my table. If I update my table, the next decoding step, I'm going to use this, right? Aha. So then, see, that's the synchronization that you need. Without the synchronization, you will not be able to decode. Okay? And you can simply, if you doubt what I claim, you can simply go home and try to work out the decoding of this BCCBA and convince yourself this actually works. Okay? And that's why arithmetic coding is so adaptive. Okay? Because we tabulate the frequency as we move along. And we don't need to have a 2-pass algorithms, right? We don't need to compute all the frequency, design the code, then go back and do encoding. We just do encoding, decoding along the way. And it's so nice. We send one number over. Done. Okay? So let me stop here because we're running out of time.
Okay, that Shannon is better than Huffman. So we cannot say that Huffman is better than Shannon.